All right. That. Okay. Okay. So I am recording this for Egan. We're going to start on your first questions. Let's see. Let me get to the right page. All right. Okay. On 302, 1 through 24, 13, 14, and 17, I will, let's see how they are very similar. I will work 13 because I've already worked 14 on another video, and I will get you started on 17, and then we'll move on to the next page. Okay, so you just watch. Let me see if I can get this closer so you can see. All right, so on this, on number 13, we start out with the square root of x plus 2 is equal to x plus 2. Okay, and your first goal is to isolate the radical, which means put that and only that on one side, which is already done for you. Okay, so that is very similar to number 14. So you're going to do the same. Well, it's already done for you. So we square this because we want to square it to get rid of the radical, right? So then this gets rid of that radical. So this is left x plus 2 equals. Now, when we square this whole thing, it's like FOILing. Okay, so square the first term. And do you remember when we multiplied these two and doubled it? You get your middle term. Okay, and then you square your last term. Okay, now the whole instruction for this is to solve. So we're trying to figure out what x is. So we want to pull everything to one side and have the other side equal to be 0. So like this. Okay, so what I'm going to do is instead of pulling this to this side and making it a negative, I'm going to actually pull both of these over to this side, and then this side will be my 0, and I'll flip it. Okay, so on this will stay on the right side, and I'm going to move the x. Remember, when you're moving it, you have to do the like terms. All right, so this became 0, and that's right here. So I'm flipping it around. Nothing has to change when you flip things around. So then I combine these two, and you've got this, and then you're combining your constants, and you have this. So hopefully you can see that. Okay, and this is what we're going to solve for. So at this point, you think, okay, I need to use the 0 product rule, and I need factors of 2. First of all, you see how these are both plus. We can fill in what we know. This is what we did right before spring break in the classroom. Okay, and factors of 2, when I add them together, because you're dealing with FOIL. Okay, so this is the first, this is the outside inside added together, and this is your last multiplied together. So we need to get 2, but when they add together, they get 3. And hopefully your brain just went right to that and you did this. Now we're not done at this point. We know that this times this equals 0. So this has to be 0, or this has to be 0, or they both could be 0. So we're going to deal with that. Let's see. Let's see. Sorry, I had a phone call. So x plus 2 equals 0, and then x plus 1 equals 0. Okay, minus 2 minus 2, x equals a negative 2. And then you do the same thing over here. Okay, and you get these two. Now, the end result, before you say that this is our answer, you're going to plug those two in to your original problem and see if it works. Ignore the 2 and the squared over here. You're going to see if the square root of -2 plus 2 is equal to -2 plus 2. And you will find that both of these do work, but that's how you're finding out. If one of them didn't, then you call that an extraneous root, and you would cross it off the answer. But both of these, in this case, work. All right, so 14 has worked very similarly. So before I do, let's see. Now let's look at 17. I'm glad you asked about 17 because it's very similar to a test problem, I believe. I could be wrong. I can't remember. Okay, so we have this and this. Okay, now remember our goal is to isolate the variable, not variable, sorry, wrong thing, radical. So we want this to be by itself. So I'm going to move that m over here. Okay, so it went away and we have 1 minus 3m equals 3 plus m. Okay, so then we square and we square. And at that point, I believe that you will be able to do this just fine on your own because this is where we are. And this was very much like number 13. So you're going to solve it the same way. So in order to keep this short and sweet, I'm going to let you finish solving that. Okay. And then you asked also for on page 310, 1 through 8. And I'm assuming that you've watched the video for this. If you haven't, there is an entire video on this lesson. It was on our Zoom. And so you should have gotten the link via email on Tuesday. So I sent it out. Let's see, we had the Zoom at 11:30 and there were about 5 kids, maybe 4 kids on the Zoom. And I recorded it, sent the link to y'all. So if you look on Tuesday's email, if you haven't watched it already, it will be around 12:30 or 1 that I emailed it out. All right. So let's look at number 3 and number 4. I'm going to work just one of them, and I'm going to work the harder one. Well, okay, I'll get you started on both. Okay, so 3 is a little different because when you're dealing with this, okay, sorry, that's also equal to 0. First thing that we did is 1, you should notice that there's no middle term, right? There's no x term. So the only thing that we've dealt with that had no x term is when we dealt with conjugates. And they were the opposite sign and the middle term disappeared. But this is not a perfect squared and neither is this. So hopefully you see that 2 goes into both. So we factor that out, pull it out. Okay, and then you have this right here. So this can even be further factored like this. Okay, and then so you've got x minus 3 equals 0 or x plus 3 equals 0. So you got 2 options there, and I'll let you finish that. But that's the majority of the work on that. On number 4, okay, very similar to number 3, but you do not have to factor anything out because there's nothing that goes into 9 that also goes into 64. But what do you notice about both 9 and 64? Hopefully you notice that they're perfect squares. So you can look at this. Remember, there's no middle term, so you need it to be a conjugate, okay? And you have to have them the same, okay? So for this, it works out perfect because these multiply to be this, and they're the same. What multiplies to be 64? Being the same. Hopefully you got it, okay? And then you're just going to set both of them equal to 0 and solve for x. So you're going to move your 8 over and hopefully you see what to do with your 3. So there's 1. Your other factor is this. You're going to set that equal to 0. But notice you have 2 different ones, so you need to do both of them. Okay, so you should have x equals and then a number here, and then x equals and a number here, and just plug those in quickly to just check and make sure they're not extraneous roots. All right, so that is all. Let me know if you have any other questions. All right, thank you.